Greetings and welcome, friends. Mr. Waddy and mis amigos, my algebuddies, hanging out here. We're talking about point-slope form, which, let's be honest, is so much better than slope-intercept form. Point-slope form can do everything slope-intercept form does and more. So it is this form here in which we have a slope m that can be derived from it, as well as a particular point x 1 comma y1 that our line passes through. As a result, there's actually infinitely many ways of writing an equation in point slope form, but we're gonna write it in the one that they gave us. So it says the following, Cameron: f of 4 equals -2. You could think about that the input is 4 and the output is -2. And f of 8 equals 4. That means when I input 8 into the function f, I have a output of 4. So that means I could rewrite that as the point 8 comma 4. So these I can now use to find the equation of my line. I have 2 points. I only need 1, but I've got to find the slope. So we're going to use the slope formula. So here's x1, y1, x2, y2. And let's find our slope first. Sloppy slope. So m is equal to y2, which is 4, minus y1, which is -2. That's why it's not a bad idea to label these so you don't make mistakes, right, Cameron? You with me? Over x2, which is 8, minus x1, which is 4. And yeah, the double negative does become addition, thank you. So that's 4 plus 2, which is 6, over 8 minus 4, which is 4. And m equals 3/2. How did you reduce that? Yeah, so like what number goes into 6 and 4 is 2. 2 goes into 6 3 times and into 4 twice. Yep, good. So here's my slope, and now let's write our equation in point slope form. I can pick either point that I want. I'll pick this one this time. And I'll plug it in. So y minus y1 minus a -2 becomes +2 equals m, parentheses, x minus x1, so minus 4 right there. So there's the equation of the line in point slope form. And we should probably write it in terms of f of x. F of x is the same as the output, or y. So how do I solve this for y? Yeah, we'll distribute, I think is what you're saying. Ooh, and I showed you guys that good trick on dealing with fractions. So this is 3/2 x minus 4 divided by 2 is 2 No, wait, 4 divided by 2 is 2, multiplied by the 3 is 6. It's all right, we'll get there. And now how do I get this y by itself? -2 minus 2. That's fine. Perfectly legitimate. And because these are in function f notation, I should probably rewrite this as f of x equals 3/2. That's a terrible 3. Because they were referring to it as function f the whole time. Well, it's a function in terms of x. Just like y is a function in terms of x. X is the input, y is the output. It's another name for it. It's another way of writing it. Is good stuff. It's good stuff. So let's take a look at this next one, example 4. A little bit. All right, the student council is ordering customized foam hands to promote school spirit. I think their mascot is a hand, I'm guessing. The table shows the cost of ordering different numbers of foam hands. Can the situation be modeled by a linear equation? That's question 1. And then, if possible, write a linear model that represents the cost as a function of the number of foam hands. Okay, so that means my input is number of foam hands. The output is the cost. Is this linear? Do you guys remember all the way from like 3.2 how we determine whether or not a table is linear? How do I know if this is linear or not? Functions have a constant rate of change. So linear functions, constant rate of change. The rise over run is going to be the same all the time. So let's see. So 34 to 46 is going up 12. There we go. And it's going horizontally, because this is my x, over 2. And let's see if that pattern continues. So let's see. Up 12. Yep. Over 2. Up 12. Man, I keep writing that 2 first. Over 2. And up 12 over 2. So this is linear for part 1. Yes, it is linear because it has a constant rate of change. A constant rate of change. Yes, so these are the y's. Yep. And the x's are the t'other ones. Y over x. Yes. Okay. What are you thinking of when you say y over x 12 over 2? You're thinking of slope, right? So you're already looking at this and saying, aha, the change in y over the change in x, the rise over run, is 12 over 2. So our slope is going to be 6. And each of these represent a point. So this is like x1, y1, x2, y2, x3, y3, x4, y4, etc. Which point do you guys want to work with? 1070? All right, doesn't matter. So if this is my x1, y1, let's write this in point slope form. So it's going to be y minus y1 equals m. You can't. For slopes, we can simplify, but that's a really good point. I can't simplify that. No, I don't think so. No. So guys, let's see. We're gonna have y minus what? Yep. Yeah. All right. So you found the slope, and we didn't use the y-intercept. Actually, how do I know that none of these points were my y-intercept? You guys remember that trick? Y-intercepts have what as their x-coordinate? All right, actually, that's super valid. None of these are my y-intercept because none of the x-coordinates are 0. And then the student just said that if I buy 0 foam hands, hopefully I'm paying $0. Maybe that's the case. I hope so. So check this out. I actually have plotted these points in Desmos right here. Yeah, it is a little bit bright. Man, that's rough. Ouch. Our eyes. So let's see. Our equation was what? Y minus 70. So watch this. Y minus 70 equals, what was our slope? 6 parentheses x minus 10. Look at that. We now have a model that perfectly represents this data. Now, you had just mentioned earlier this. What would 0, 10 mean? You're paying $10 for 0 hands. And so this data does not make sense in that instance. $10 for shipping, maybe? Wow, that's a really clever way to think about it. Yeah, maybe it's $10 for shipping. Question. Is it? No. So she's not taking a test. So anyways, the y-intercept b was equal to 10. You were just hypotheticalizing that what if $10 is shipping? If $10 is shipping, what does it cost per foam hand? Why? Yeah. So the slope is rise over run. The y coordinates represented cost. The x coordinates represented foam hands. $6 over 1 hand. That is the cost per hand, right? Cost per hand. So that does appear to be the case. And then the cool thing is once you have a mathematical model, you can then use this to predict. Now, does this make sense as a solution? Let's see. I can't click that anymore. I don't think I can buy 17.708 foam hands. That doesn't make sense. But I can use this as a predictor, say when it lands on 16, if I could do that perfectly. Right, I could predict future costs if I wanted. It looks like it'd be $106 in that case. And then I could even say, if I want to have a bulk order, all right, what would 400 foam hands cost, do you think? Yeah, it looks like around $2,400 for 400 foam hands. Devin, please. So I could use this to predict things. What does this point represent in terms of my model? Right here. So it doesn't make a lot of sense. That would be like, instead of them charging me $50, they're paying me $50, and I'm selling them 10 full foam hands. But I doubt many businesses are interested in that. So that doesn't really work out. All right, let's see. I think I'm good for today, friends. Thanks for watching. Bye-bye.